Hi everyone, this lesson is going to be demonstrating how we can use our technology, Excel, to calculate some statistics for us when we're doing least squares regression lines or lines of best fit. So I have some bivariate data here, just totally random made up data. And I've got a scatter chart with the points there. You can see if I click the points, they're highlighted. And I have asked Excel to put in a best fit trend line, including the equation of the line and the coefficient of determination, also called the R-squared value. Now that's lovely, and that gives me great example of the use of technology. But when I'm writing my assignment to be assessed, I also need to show complex use of mathematical procedures. Now here's a little excerpt from our formula sheet down here. And the line of best fit, you'll recall, it is y equals a plus b times x. So this number here is a, and the number 2.69 is b. And we have formulas for these here for the least squares line, the slope and the intercept a. Now, we can pick to use this formula or this one here at the side. I prefer the smaller one. We'll need to know b in order to calculate a. You see how we need the value of b there? So first thing is to calculate b. Well, how do we calculate b? We need r. How do we calculate r? We use this formula down here. I see that this formula down here uses n, the number of data points. Well, let's first of all figure out how many data points we have. So I'm going to do some working. I might move down a bit so I've got space. I'll just put n equals, that's just text, so I can remember what's there. Equals to start the formula. And on Excel, I say count, and then I just highlight the X column. Now, there are 7 numbers. I don't need all those zeros there, of course, because it's just counting. I wouldn't count both of them, otherwise I'd get 14. There's not 14 data points, there's only 7 data points. So just count the X's to get N. So there's that bit done. Now, pretty straightforward. Xi, the little I stands for every individual value. The X with the line on top of it is the mean of the X's. Now, how do we calculate the mean? Well, the mean of the X's is the sum of all the individual X's divided by N. So I will need to know the sum of all of these. I think I might just write the word sum here at the edge. It's a bit low, I'll put it here. I'll write the word sum, so I remember. Now, there is a command to do this. Equals to start the formula, then sum, then the brackets, and we highlight those. Got it. The sum of those is 42. The sum of the x's. That's literally what that symbol. Sigma is the sum of xi individual x's. So the sum of the individual x's is 42. I might put a little bit of color on the back of that just so I don't mix it up with a data value. Now, if I want to know the mean of the x's, then I'll do a calculator. I know there's a formula that Excel can tell you, but we're trying to show our working here in our report. So the mean of the x's, according to this, is the sum of them divided by n. So it's this number where the sum of them is stored divided by this number n, and I get the mean of them. Now let's just bring up our word processor for a minute, and we'll see about how we could start to type that up. Now, of course, the Excel spreadsheet doesn't get submitted. Well, sorry, the Excel does get submitted, but it's only there for your teacher to validate your work. The thing that gets judged is what's in your report, isn't it? So we would start by telling the reader what we're doing. So the mean of the X values is calculated. Oh, typing is hard, isn't it? As follows. Now, I'm pressing the Alt key and the equals key. It gives me an equation editor. I want to type the formula. So I can go up to here. You see this one with accents? There'll be one down here somewhere with the little line. There it is, the little bar. And then I can put the X in there, move to the right, equals. Now I need a fraction. I can type the fraction key, then the space bar, and it jumps into a fraction. The one at the bottom was n. The one at the top was the sigma, the x, and the i's. So it looks like we've got things, there we go, sigma, and in here I want x with a little I at the bottom of it. Now there's a trick. You can press the shift key and then the underscore. That's the key just to the right of the 0 on the top of the keyboard. Then the letter I. Then when you hit the space bar, it formats it for you. So there's my formula straight from the formula sheet. Now don't go outside the formula box. Stay inside the formula box. Hit shift enter. It drops a new formula box in there for you. Equals, do a fraction. Now I'm going to copy the numbers. The sum of the numbers was 42.00. The number of scores, n, was 7. Then I did a shift enter again, and my answer for the mean is 6.00. Now I'm going outside there and I'm just hitting enter once or twice. This is neat, but it's neater if the equals signs are all lined up. So I'm pressing shift and just the down arrow. Now I went a bit too far, I'll press the left arrow. So I'm highlighting just the equations. I do a right click and then I say align at equals, and they're all neatly lined up. So there is my working that goes in my report to demonstrate the formula. It demonstrated that I knew what the sum of the x's, that I didn't have to type them all on my handheld calculator. I don't have to write them all out. I can simply show this to say that I've done the working. So that's the mean of the x's. Now let's go on with the rest of our calculation. So we've got the mean of the x's, lovely. The next thing that I need to know, well, in order to calculate this thing, I'll need the standard deviation of the x's, won't I? Sx. And the standard deviation is given by this formula here. It's a lovely formula, but it's a bit more complicated. Inside here, we have x, the individual x's subtract the mean. So that's really the deviation of the x values. So again, that's just a heading. I'll put equals, and it's the individual x, this one, subtract, so I'm reading from down here, subtract the mean. Now the mean of the x's is there. I always want to subtract 6. When I copy this downwards, I certainly want the blue reference to copy down, but I don't want the red one to move. So press the F4 key to lock in that reference. So my first deviation, yes, this number is 3 below the mean. That's what the negative is. I'll just copy that down, and I'm happy with that. Those are the deviations. That's the bit inside the brackets. Now they have to be squared. You see the little 2 there. So I'll get Excel to help me. The deviation of the x's squared. Now again, that's just convenient things to type. Here's the formula. Equals the number stored beside it there to the power of 2, and it squares it for me. Let's copy these down. So far so good. I note that there's a sigma symbol in front of those deviations squared. That means add up all of the squared, add up all of these numbers. So I've already got a formula there that added that column. I could drag them over. I can just drag them over. There it is. That number, 28, is the sum of the squared deviations. Good. I'm going to calculate out the standard deviation for the x's. I'll just put this down the bottom here. It's the standard deviation. Oh, I can't type very well today. The standard deviation of the x's. Here we go. Now I'm going to try and use Excel to do this calculation. It starts with the square root. So the command is sqrt for square root. Then everything goes inside brackets. What's the number on the top of the fraction? It's the number we just figured out there, 28, divided by n minus 1. Now n was 7. I could just type 6, but I think I'll go like this. 7 minus 1. See how the red brackets are the denominator? I still need another bracket to close off the square root formula. And there it is. That's the standard deviation of the x values. So now I'm going to have to put that into my working, aren't I? So, oh, I should have had a full stop at the end of that sentence. Oh, that ruined it. Sorry. Yeah, I might just finish that sentence there. Word gets a little bit funny when you mix mathematics and text. It jumps all over the place. So try not to mix your mathematics and your text in the same line. Okay, so we got the mean, lovely. Then we did the standard deviation, and it was a sample, not a population. The sample standard deviation of the x values follows. So once again, new line, alt equals. Here comes my formula, s underscore x with a space bar equals. Now, I can come up to here and grab a big giant square root sign. Inside the square root sign, I'll do the fraction. Now, the top of it was sigma, and then in there I had brackets. Inside the brackets was x underscore I spacebar minus, and the mean of the x's will be, have to put that one with the little bar there, and put the x, and just to the outside of the bracket I go to the power 2, spacebar formats it, all divided by n take 1. Now that's the worst part about it. Shift enter to give me a new equation. So now I need to do, well, I don't have to do the whole thing over again. I can copy that bit, make sure I'm inside the equation box. Now I will just take out a few of these little bits here. Now the number that I needed at the top of that was 28, wasn't it? All of the deviations were squared and then added, so the number that goes there is 28.00. And I could put 7. 7's fine. 7 minus 1, that's easy. Shift enter. And now the answer was 2.1602. 2.1602. So I've done my complex mathematical procedures. Remember, press enter a couple of times, highlight just the equations, if I can just manage to just do the equations, and align it equals. Looks beautiful. That's going to be how I match up the work that I'm doing in Excel with the formulas and putting it into the body of my maths report. So I've given the working and I've shown my teacher that evidence of complex mathematical processes. Even though I didn't type them all on my calculator, Excel did the hard work for me. I'm writing a report to show the working. Now there's more to be done, isn't there? I will pause for a moment because I notice that we need the standard deviation of the y's. So you don't need to see me do all that again. Let me pause and I'll be back in a tick. Okay, here we are. I've completed the same process with the y variables. You'll see there is now a mean of the y variables. There is a deviations for the y's, a squared deviations. I've added the column, and then I've calculated the standard deviation of the y's. Now, if I were writing my report, I don't need to show the same level of working for the mean and the standard deviation of the y variables. That's a repetitive calculation. I can simply report the answers. I can say the mean and sample standard deviation of the y values was calculated in the calculated by using the same process. So now you can actually put an equation into a sentence if it's appropriate. So I'm going to say, so here we go. Oh, I did something wrong. Try that again. So alt equals to get the equation, and I want to do a mean with the little line. I'll put a y under there. The mean of the y's equals, and we can see down here the mean of the y's was 18.28. So I'll type 18.28. Move outside the equation. Now keep typing. And the sample, try again, and equation, Alt equals, and I want to type S with an underscore Y spacebar. That should have probably been a lowercase s, not an uppercase s, equals, and my standard deviation for the y's is 6.2212. 6.2212. Go outside the equation and press the full stop. There we have it. Oh, I broke it. Sorry, something went wrong. Oh, something very wrong there. Okay, fine. So we've got that done. There we have it. We've got our working shown in detail for the mean and the standard deviation of the x's, and then we've used the same processes, and we've got our answer there for the y's. Let's move on. We now have enough information, I think, to calculate the value of R. So the value of R is given by this formula. Now you'll notice that there's a little bit of something happening at the top here. Xi minus the mean, that's the deviation of the x's, that's that number. Then yi minus the mean of the y's, that's that number, the deviation of the y's. I need to multiply them, don't I? In fact, I need to divide them by their standard deviations and then multiply them. That's going to be big, isn't it? Let's see if we can type. Now the heading at the top, oh boy, what am I going to type? It'll be the deviation of the x's. Didn't type that very well, did I? Deviation of the x's multiplied by the deviation of the y's. Remember, this is just our label, so we know what, or we remember what we're looking at. And each of these it's divided by sort of sx times sy, sx times sy. That label's too big to fit. That's better. Now let's go ahead and calculate this. I'm pretty much going to do it the same as what it shows there. I've got a bracket. I'll pick the deviation of the x, multiply by the deviation of the y, close the bracket, divide by, new bracket, the standard deviation of the x, but that one's always fixed in place, multiplied by standard deviation of the y, and that one's always fixed in place. Close my bracket and hit enter. So that's the first value calculated in the sum of all those values. So I'll copy them down my table and I'll copy that summation. There it is. The number that goes there in my table is 5.61. I would have to go 1 over and take 1. Well, I think I can do that. R equals, this is the correlation coefficient. So I need the big giant number, that one, divided by, in brackets, n take 1. So there's n, subtract 1. I have a correlation coefficient for this graph of 0.9356. And you might sit there and go, wait a minute, that's not what Excel told us. Be careful, this one is R squared, the coefficient of determination. They're different things, aren't they? Now it's very easy to find. Here we go, I'll just go that number there to the power of 2. And I don't know why Excel did that, that's so annoying. Let's reduce that down. And then I'll shrink that column back to the way it should have been and to start with. So that number, coefficient of determination, matches what Excel told us, doesn't it? So we've got the value of R. Now we'd better try and put this into our report by using that formula. I'll pause while I do that. Okay, back again. So here is my example of what I would do. It's a new calculation. I have to show the working. There's the formula typed up in the equation editor. And again, n was 7, so 1 over 7 take 1 is the first part. Then this part here, the summation of all of these things. Now I seem to have a stray bracket in my formula, so I'll just edit that. So that's all of that stuff, remember, was the number at the bottom of that column because we did the calculation for every individual data point and then added them up to get 5.61. This gives me my value of the correlation coefficient. Be careful, again, to use the right terminology. Now, we probably want to find out the coefficient of determination, and that's just squaring that number, isn't it? So that's just a short statement. From this, the coefficient of determination is found. Now, typing is hard some days, is found as, here we go. So let's do an equation. Let's do straight away. Capital R to the power 2 will equal, and I'll just type 0.9356 squared equals, now I have the number over there, 0.8754, 0.8754. Outside the equation, full stop. And there I go. That's such a simple one. I don't think you really need to set it aside as a separate formula. It's a little bit of a grey box in there for some reason. Don't know what's going on with that. So we've started to produce a report as we're going with doing this. Now, the next bit's quite straightforward. We want the gradient of the best fit line B. And now we have all the things over here that we need. So let's just find a convenient place. B equals, and it's the correlation coefficient. Here we go. It's R. It's that one, not the R squared, multiplied by, and it's the standard deviation of the Y's. This is this one, divided by the standard deviation of the X's, this one. And that 2.6944 exactly matches what the Excel automatic formula gave us. Let's finally do A, the intercept of the straight line. We'll be using this equation here. The mean of the Y values, well, we had the mean of the Y values there, and then we subtract, and we go B multiplied by, so that one is B multiplied by the mean of the X values was there. And we have 2.1162, exactly matches the Excel automatic formula. So we've now completed the working in Excel, and we would need to show those formulas there for B and for A. I'll pause for a second while I fill those in on my report. Okay, so here we are back again. Now it's been a bit of a marathon, but we're almost done. If we go and take a look in the report now, so we got to that one last time, and I said finally we're ready to calculate the slope, B, and the intercept, A, of the least squares line of best fit. So here's my formula from the formula sheet. These three numbers here match the ones which were on my spreadsheet, and then the number 2.6944 is the slope of the line. I then followed immediately with my second formula, and there's the answer. Those numbers match what's on my spreadsheet. So the statement then, the conclusion is the best fit line for this data has the model, and a model is an equation, Y equals, now it's the A value, 2.1162, plus, and it's B times X, 2.6944, 2.6944X. That's my, yep, with an, here we go, R squared equal to, and we had that one from earlier, so we're just summarizing, it's 0.8754. Had an extra 5 there, 8754. 0.8754. Full stop. Now that is a pretty long video, I know, but I'm trying to make it clear how you can use your spreadsheet and then you can show the mathematical justification. Remember, don't do repetitive calculations. You would want your data table in here as well, wouldn't you? Now, here's my data table. That's really the important bit of my data table. Let's copy that data table. Let's put that here into my, I went over the edge of the page. That's probably because everything was too large. That's a formatting issue. Now, my data table is quite small. Yours will be rather big, I feel. So it could be the case that I don't have space in my report to include all of the data. So I'd probably just put the headings. I'd put maybe the first 2 or 3 rows, then I'd blank out everything in the middle, and I'd probably put the last row and the last one here with the summations as well, because those numbers, like the number 42 appears here, which is a very important thing to match up, and the number 28, it appears up here. It's important to match that up. So I'm going to stop the recording now. I think I've given enough detail, and hopefully that's given you a little bit of guidance. I know this is one of my longer ones. Thanks for staying with me, and I'll see you next time.